Okay, so hi everyone, and welcome to the session on 6 lessons I learned on my journey from Monolith to microservices. Now, before we deep dive into the content, I'd like to start off with a short video I created with my colleague about various journeys we've seen from Monolith to microservices. All I can say that this is actually based on true stories we heard over the past couple of years. So let's take a look.
Te he contado lo de cuando me cogió una la Guardia Civil, te he contado esto, lo de mi perra, esto. Y llegué allí, sellé y llegó un tío, uno de Valencia, para descargar un trailer de botellas de aceite. Y lo escuché yo. Joven, de 20 a 30 años, y que sean gordos. Y le van a dar 20.000 pesetas a los 4 que se apunten. Y hay que descargar un trailer de botella de aceite, dije yo. Un trailer de botella de aceite a 4 garrafas en cada mano. Juan Joya, sí, pum, pum, y hay uno. Y mi amigo que vino también conmigo, de las Candelarias, se llama Gregorio. Yo también me apunto. Y cuando nos vieron entrar, ¿esta gente son los más gordos? Sí. Oh. Ay, Dios mío. El tío entró, el de Valencia nos metió para adentro, el del chope, del coche, para adentro. Ay, ¿ustedes 6 los que venís del paro? Sí. ¿Quién se va a cargar de esto? Y pues lo quita el norte. El tío se quita del medio. ¡Ay! Era el saco del cemento. Jesús. 600 sacos. Y dije yo, señora, no eran botellas de aceite, de aquí no se escapa nadie. Eso hay que descargarlo. 600 sacos, tú, tenía que llevarlo a otro túnel. Y me daban otro saco para llevarlo pero mírame, que te estoy hablando, descargar y montar. 600 para allá y otros 600 que me dieron. Otro saco que me daba. Mira, yo si cada saco que partí me quitaban el dinero, no cobraba. Yo ya, mira, cogía los sacos y tú, se partía y venía el camionero. Todavía iba por ahí. Que me voy para Valencia, que ya va, que salgo esta tarde. Iba a ir por la mitad, digo, no te quedan. Si no le ayuda a la fábrica, el camión no sale. Tú me daba mi saco y me caía al suelo. Yo ya cogía los sacos, los arrastraba.
All right, so like I said, based on true actual stories. This is available on YouTube, so you can find out later. So my point in this talk, in the next 50 minutes or 45 that we have, is to first start off with just a little bit on the hype of microservices and what microservices are. I assume that most of you have already heard of them or know them. And for the bulk of this talk, I'm going to talk about lessons that I've learned seeing many customers going from Monolith to microservices, and then we're going to have a couple of minutes for QA at the end. Now, there is no code in this session, so if you're looking for code, you're not going to get it. We're going to talk about high-level principles that, again, to help you not to get into the situation which we saw in a movie just a second ago. So my name is Eran Stiller. I'm the CTO of a company called Code Value. We're a software services company from Israel. I'm a software architect or a consultant. I've been working a lot with cloud-based systems, mainly AWS and Azure for the past couple of years. And that's why I'm also recognized by Microsoft as an Azure MVP and a Microsoft Regional Director. So let's start a bit with microservices. Microservices weren't born in a day. They weren't invented like just out of the blue in someone's head. No, they're an evolution of the way we wrote software over the years. If we go back to the 1990s or even before, we've written applications in a way that now we call a monolith. We didn't call it a monolith back then, but actually we wrote a single piece of runtime executable, which we ran on a server or on a PC, and that's what we had. I mean, we did put principles of design and architecture on this monolith. We used classes, we used components, we used assemblies, we used DLLs. We tried to write it in a good way. But from today's perspective, all these components were rather tightly coupled. Fast forward a bit to 2000s, and so I emerged service-oriented architecture. With service-oriented architecture, we understood that the systems we were building were a bit too large, they were hard to maintain. So what we did is we decided to break things up into several smaller services, which was still rather large compared to today. And they spoke over something that's called a service bus, which is some sort of smart pipe which allows to discover services and messages and so on. Lately, with the evolution of the technology and the platforms that you use and stuff like Docker and Kubernetes, we've moved on to microservices, where we have multiple small parts where the features are achieved by integrating these various small parts over various communication channels. It could be HTTP, gRPC, messaging via queuing, and so on. Now, microservice architecture has some important principles. The first one being is that each microservice should be small. Now, the original theory that coined the term microservices stated that a microservice should be less than 100 lines of code. Now, I don't take the number as something simple, meaning how do you count lines of code? Do you count white spaces? Do you count importing namespaces, stuff like that? No, the idea is to keep the microservices small. As long as the microservice is small, it's easy to understand, it's maintainable, and for example, one metric you can use, if you can develop it in one development sprint, then it's small enough. It doesn't matter if it's 100, 200, or 1,000 lines of codes, as long as it does one thing and it does it well. And that's the most important thing to remember. A microservice should be independently developed and deployed. What that means, if you have a couple of services, you should be able to deploy and upgrade each one of them independently of each other. What I usually tell my customers is that if you need to tell someone that you're upgrading your service, one of the microservices, then you're doing something wrong. Because someone else is dependent on you in a way that doesn't allow you to deploy yourself on your own. A microservice should support versioning, and we must have versioning in order to allow upgrading our service without affecting anyone else, to allow for backward compatibility. And a microservice should have private data ownership. And by that I mean that in classical systems, we had our application, our UI, our business logic, our data access layer, and we had the database, one big database that everyone wrote the data into, and it had one big schema, and that was just fine. In microservices, we try to avoid that, because if more than one microservice shares the same database, then we have a dependency. Because if one microservice requires a change to the schema, other microservices relying on the same database must be upgraded as well. And so we have a distributed monolith because you have tight coupling between the various services. So we try to have private data ownership. And microservices is all the rage these days. Everyone's talking about microservices, everyone's talking about Docker, everyone's talking about Kubernetes. Everyone wants to move to microservices. And that's great. And I've seen various customers come to my company and tell us, we want to move to microservices. And during this project, we've learned a couple of lessons. Some of them are rather simple, but if you try to stick to them, it will help you avoid many of the problems that you get once you start building real systems with microservices. So let's start. And let's start with the first one. Do it for the right reasons. Whenever I get to a new customer, the first thing I ask them is, why do you want to do microservices? What is the reason that you want to do this huge, complicated thing? And I get many answers, and I've managed to divide them roughly into 4 categories. The first category is, it's cool. Now, they won't say it's cool. They won't say it's awesome. They say everyone's doing it. Kubernetes is awesome. We should use Docker. The other company down the hall does it, and they're doing great. Stuff like that. Basically saying something about technology without really understanding. Now, I want to ask you a question. By raise of hand, how many of you think it's wise to invest millions of dollars in development for something just because it's cool? No one, not surprisingly. But this is an answer I get. Again, not in this term that it's cool. They're saying other things. But it's a tendency to do something because it's hot, because everyone's doing it, because everyone's talking about it. But this answer usually comes with another answer. I get an answer which says that it's easier or that it's faster. And it has reasons to it, because they see, for example, that on Kubernetes, you don't need to manage a lot of the infrastructure, and you get the domain name service, and you have built-in configuration management, and it takes out a lot of the load for you. And that's true to some extent, but you should always remember that microservices have a learning curve. I had one customer, a real customer, a small startup company, and they wanted to build a new system, and their goal was to get an MVP of the product out to customers in 1 month. Okay, 1 month to get a product out. Now, it doesn't matter what they wanted to do. 1 month is rather tight. And they wanted to do it with microservices. Again, because it's cool, because they're a startup, because everyone's doing it, and because they actually thought it was faster. That's what they knew. But when we sat down and went over the things they'll have to do of setting up the infrastructure, setting up the DevOps process, all the CI/CD pipelines, multiple Git repositories, architecture of the microservices, all the learning curve they'll have, and the developers they need to get, or the DevOps personnel they need to get, they understood it will take more than a month. I advise them to do it the classic way, in quotes, using a monolith. Why? Because the classic approach, if your goal is to have a fast time to market, if you want to get a product out there as fast as possible, and you don't have a lot of money to waste on it, you don't know where you're going yet, use the classic approach. Don't do microservices. It will shoot you in the foot later on. So time to market is not a good reason to do microservices. But there are actually good reasons to do microservices. One of them is scale. And by scale, I mean 2 different things. One is the scale or the throughput of your system, the amount of users you support, the requests per second, the concurrent connections, however you measure your system. Systems built with microservices are typically easier to scale than monolithic systems. And the reason for that is that in a monolith, we have one big thing that we need to scale. Sometimes it's hard to scale it. When we're using microservices, again, when they're done right, we typically only have to scale the small pieces that are under load. And once we scale those, we can get much better throughput. But there's another meaning to scale. It's not the amount of users or throughput. It's also the scale of how many developers your company can have and how many developers can work on the same application. And I want to ask you a question again by raise of hand. How many of you work on a code base where there are more than, let's say, 10 other developers working on the same code base? Okay, quite a lot. Keep your hands up, keep your hands up. How many? More than 20 developers? Okay, a little down. More than 50? Okay, wow, few hands up in there. Should give them a round of applause. They're courageous for working with so many developers. I actually had a customer come in, and they were a big company. There were like 1,000 employees, and out of which about 300 or 400 were developers. And they came to us and said, we want to move to microservices. And I asked why, because that's the first question I ask. And they said, we have so many developers working on the same code base. We need to keep coordinating between everyone, because one developer in one division is working on one thing, the other developer in another division is working on something else within the same code base, And they need to merge everything, they need to coordinate, they need not to step on each other's foot. It's not a nice experience. Once you use microservices, you can partition your services and have each service assigned to individual, either developer or individual team. And that makes developing it in the long run much easier. Once you do that, it also allows you to achieve better agility. And I think agility is the best answers of why to do microservices. Again, real story, came to a customer, wanted to do microservices, why? They told me, from the moment we have an idea, to have a requirement, up to the moment we get it into production, it takes between 6 months and 1 year to get from a requirement to production. Why? Because the code base was so convoluted and it had so many developers working on it, it was hard to coordinate a feature and get it all the way end to end. It took a lot of work. And remember agility, I have some real numbers, research I'll show you later on in this presentation. So that's doing it for the good reasons. Let's talk about evolution or evolution. When you're building a new system, you don't have a problem. You just build a new system of microservices and that's it. But what happens when you have an existing system as a monolith? You have a lot to lose. You have customers, you have people using your system, you have management asking to add more features to the existing systems. You can't just lock yourself up in your room, go back out, I don't know, a year or two later and say, oh, look at this nice thing that we have. What does it do? The same thing. That won't work. You'll probably be shut down before you even start. So you need to think about how you handle this transition. And there are actually two approaches. One is the evolution approach, where we transition from the monolith to microservices over time. And there are various approaches to this. Actually, there was a session yesterday showing some of them. For example, you can rip small parts out of your monolith and turn them into microservices and change the monolith to use the microservices. Or you can put paint over rust, as I call it. You can take the monolith, you can coat it in a layer of APIs, which would represent your microservices, and have new microservices calling to the monolith as if they were implemented correctly, in quotes, and then, again, do the transition over time. That's one approach. Another approach is the revolution. Let's throw what we have and do something new. Now, usually you'd want to go with the evolution, but you can't do that always. Let's look at a case study. One of our customers was a large-scale multi-tenant trading system. Think of it as some sort of business-to-business trade center where multiple businesses sold and bought various things. And this system was written in .NET. It was running on IIS, on VMs in AWS. And it used the MySQL database to store all the data. A classical system, and it got to really big, really huge scales. It was working rather nicely. But they wanted to move to microservices. Why? Again, scale, the number of developers, and agility. They had the good reasons of moving to microservices. So we said, OK, how are we going to handle this? And in this case, we decided on evolution. And the approach we took is that we're going to write new functionality as microservices. We're going to take bits and pieces from a functionality from the monolith and write them as microservices, but we're not going to rip them out. Because ripping out functionality from a monolith is hard, because if all the monolith uses the same database, then you never know where to expect who needs which data. So what we did is we created the microservices on the side, we kept the monolith, but every time a microservice needed to make a change to the data, they stored it in their own data store, but in parallel, they also updated the data store for the monolith, allowing it to continue running as usual. Now that creates another set of problems, that we have multiple sources of truth, and we need to consolidate between them in case of failures, which happen. But using this approach, we managed over a course or between 12 and 18 months to get most of the code to microservices and get the customer in a much better place, all the time keeping the operational system running and users using the system without ever knowing what happened. And also adding new features along the way, because new features got the new treatment. So it was nice. In another case, however, we encountered a customer which had an advanced CAD tool, computer-aided design tool. It's a 2D, 3D design tool written in MFC, C++, running on a desktop. And this tool also ran various algorithms and simulations also within this desktop app. Now, they wanted to break it up. Why? How do you break a desktop app? Because they wanted to run all the simulations and the algorithms and the heavy lifting, they want to do it in the cloud. Because one, they want to have better control, they wanted to have better performance, and they wanted to allow the desktop application to run on weaker PCs or even on tablets. So they wanted to rip parts out of this desktop application and run them as microservices and do it in the cloud. And we looked at the code and we thought, okay, how do we handle this? We prefer to do evolution. We don't want to do evolution. But the code was really just a horrible mess. I mean, imagine heaps of global variables with all kinds of algorithms putting things in there, and the order in which you execute things matters. Or business logic, which checks its state by going to the UI and checking the state of the UI control. So we have business logic going to the UI and stuff like that. A good legacy system. And we said, okay, let's give it a try. And we decided to create a POC, a proof of concept. We said, okay, let's try, take a small part. It failed miserably. I mean, we just couldn't do it. Everything we touched broke something else. We got to the conclusion, there's no way we're going to evolutionize this thing. We need to do a revolution. We need to start over. And what we did with this customer is that we built a new system from scratch on the side, a new app with a new backend and everything. But we allowed the customer to install both apps, and we allowed importing and exporting between the applications, so the customer can choose which app do they want to use until the new app reached maturity and we could shut down the old one. So that's a path of evolution. And by the way, the picture you see here is really, it's from the Florida Keys. You can see there's the old bridge, the old narrow bridge, and they wanted a new wider one for cars, for more cars. They understood that widening it would be cost too much, just built a new one right next to it, which is wider. So basically the same of what we did. So evolution or revolution. Let's talk a bit about DevOps. And really, if I have to give you one piece of advice, DevOps would be it. DevOps in companies which don't have a DevOps tradition, a DevOps culture, is underestimated. Is often they don't know the true worth of DevOps and what it gives you. Again, I'm sure all of you know DevOps. Again, DevOps is the name, a collective name for a set of methodologies, tools, and concepts which help us to connect between developers and operations personnel. Now, I'm going to focus specifically on a specific part of DevOps. And I'm going to talk about CI/CD pipelines and their importance. There are various other aspects of monitoring and such, but I want to talk about CI/CD pipelines. What are they? Again, I'm sure you already heard. A CI pipeline, or continuous integration, is where we take a developer's commit, we build it on the build machine, run some automated unit tests, maybe some integration tests, and we have an output. The output is an artifact. It could be an executable, a zip file, a NuGet package, a Docker image. It doesn't matter. We have an artifact. That artifact later on we can take and deploy to production manually. Almost everyone have continuous integration pipelines these days. This is considered common. A continuous delivery pipeline is where we take the artifact from the build pipeline, we deploy it to an environment which mimics production. It could be a QA environment, a staging environment, pre-prod, there are various names for it. We deploy to the environment, and we run tests on that environment once the entire application is deployed. And we stop there. We have the results of the test, so we can later deploy to production. Continuous deployment is when we do that extra step, and we also deploy to production automatically. Now, why do I focus on CI/CD pipelines? Why do I keep, whenever I go to a customer, I say you should do it from the start. You should not wait. You should do it from day one. There's a reason. There is actually research. It's called Accelerate State of DevOps 2019. There's actually one every year. The 2019 got out 2 months ago. And you have the link down in the slide where you can download it. It's a free report. And what they did is they went to a bunch of companies and they measured their performance. They measured 4 things. They measured deployment frequency, meaning how often do they deploy code to production, lead time for changes, how long does it take to get code from the developer to production, time to restore service. In case of a failure, how long does it take to get back a working version, and the change failure rate of the deployments, how many deployments result in an error. And among the respondents, they divided the companies into 4 categories: elite performance, high performers, medium, and low. If we look at deployment frequency, the elite performers deployed multiple times a day to production. The high performers did between once a day and once a week. The medium performers did between once a week and once a month. The low performers did a version once per month till once in every 6 months. Okay, so we can see the spread among all of these companies. The lead time for changes is very similar. The elite performers, from the time a developer checked in code until the time it got to production, it took less than a day. Why? Because they deployed multiple times a day. For the low performers, it took code to reach production between 1 month and 6 months. Again, we can rather see it expected. Time to restore service. Elite performers, in case they had an error, it took them less than 1 hour to return to the correct state. The low performers took them between 1 week and 1 month. So in case there is an error, it took them between 1 week and 1 month to recover. And we have in between. And if we look at how many errors do they have, we can see that the elite, high, and medium performers have between 0 and 15%. The low performers have 46 to 60% failure rate. So not only do they deploy very infrequently, they have a lot of errors, and it takes them a lot of time to recover. How did they spread between, all the companies spread between the various types? So we can see 20% of respondents were elite performers, 23 high performers, 44 medium performers, most were here, and 12% were low performers. So there were actually companies which were there. But what does it mean to be an elite performer versus a low performer from a business perspective? If we compare elite performers with low performers, they showed that elite performers deployed 208 times more versions to production. 208 times more deployments to production. Their lead time to take changes from developer to production was 106 times faster. So they were very agile. This number is amazing. They were 2,604 times faster to recover from incidents. Even if there was an error, they were faster to recover by 2,604 times. We can't even grasp this number. And they had 7 times lower failure rate, meaning they even failed less. So how does this relate to the CI/CD pipeline I talked about? Because I talked specifically about CI/CD pipelines and doing them correctly. So it turns out, in the report, they measured. They asked these companies, how many of you do automated builds? How many of you do automated unit tests, acceptance tests, performance tests, and so on? And also automated deployment to production. Now I'm going to show you the numbers. You might not see it in the back, but darker is higher, and the results were these. They were pretty rather correlated. So automated builds, CI, which almost everybody has. So we can see that the elite performers did 92, high 91, medium 81, that's a lot lower. And the low performers did 64% of the time. And these numbers go down as we go up the stack of how many deployments how many automation processes we can have. But if you look at automated deployment to production, you can see that the low performers did it 17% of the time, the medium performers 38, 60, and the elite performers 69. So again, it's not a real measure. If you do this, you will be that. It's not like that. But there's a pretty strong correlation here. And that's why when I go to customers, I always tell them, don't build on someone's machine on first day. They always tell me, you know, we want to get the product out fast. We just build it on someone's machine. We manually build it. We'll just throw the code somewhere. We'll just throw it over the fence to the production. It will work. And we'll fix it later. We'll add it later once we have time. And I keep telling them, no, do it today. Because if you don't do it today, you'll get errors at the beginning, and it's much harder to do it later. You incur technical debt. So DevOps is really, really important. But not only the CI/CD part, also the monitoring and all the other aspects, but that's the part I decided to focus about. So DevOps, especially if your organization is not DevOps prone. At one of my customers, they were a hardware manufacturing company, they were not a software company. If you were on my session yesterday, you heard something else about them. They didn't have DevOps at all. They were building machines to work in factories, and their software division, they built software to run these machines. And they got a new machine out or a new version once every couple of months. And one day they wanted to start sending telemetry to the cloud and connecting everything and having a backend in the cloud and an app to visualize things. They didn't have any DevOps culture, no DevOps personnel, no person who could take over this role. This is something you really need to think about when you come to this world, and especially to the world of microservices. Let's talk about the steep technology learning curve. Learning microservices is not like learning a new programming language. For example, I had a customer which was a .NET shop. They had .NET developers. And they came to us, again, true story. They came to us and they said, we want to do microservices, and we're going to do them in Node.js. Why do you want to do microservices? That's the first question. The second question, why do you want to do Node.js? Do you know what the answer was? Because everybody's doing it. Node.js is the correct way to do microservices. So they thought if they would learn Node.js, and again, learning Node.js is just learning another platform. It's not that hard for experienced developers to learn a new language. They thought that by doing Node.js, they do microservices and it'll be great. So first of all, we convinced them to use .NET Core in their case, because there's really no need to revolutionize everything. They have software assets, they can reuse them, they have existing knowledge in .NET and C#, so the transition to .NET Core would be easier. But again, they still needed to learn a lot more. How do we architect such a system? What is Docker? How do we use it? How do we use Kubernetes, DevOps, and more and more? So no need to make things more complicated than they are. And you need to remember, it's not just about the programming language. But on the other hand, the move to microservices is a good opportunity to change things that you want to change for a long time, that hurt you. So, for example, if you have a certain part of your system which should do machine learning, and you're working in microservices, so you can utilize the transition to microservices to do that part, for example, in Python, because Python is the best tool currently to do it. Or maybe some other technology that you want to use. You can take the chance and make these changes, but you need to think about it. You need to plan for it. You should do what is best for organizational culture. If you have existing skill sets in a certain language, don't ditch it in one day. If you don't have the DevOps culture, embrace it. Get some people who know it, get consultation, hire someone, do something about it. And don't remember that you must always educate your employees, your developers, your environment. And not just the programming language, but also the concepts, the architecture, Kubernetes, and so on. It's something you need to plan for and need to educate. And it could be either by using courses, online courses, coming to conferences like this, or it could be even mentoring them, Having a couple of seniors mentoring the juniors, they know what you're doing. That will come a long way and help you of doing the right thing. Now this is one of my favorites, no anarchy. What does that mean? A lot of people think that microservices are the Wild West. And what do I mean by the Wild West? There are a couple of examples. There are a lot of samples I hear, a lot of sentences I hear all the time. One sentence I hear is, let's just start and add services as required. Let's just start building it. And if we need a shipping service, we'll build a shipping service. If we need an inventory service, we'll build an inventory service. And so on and so on and so on. The problem with this approach, even though it sounds easier at the start, and it is easier at the start, it usually leads to something that's called functional decomposition. What's functional decomposition? Where we decompose our system into services, where each service implements a certain function or feature more correctly. Now, usually what will happen in this kind of scenario is that one day, it will probably work in the start, you'll have 5 services, 10 services to work, but then something will happen. Usually, there will be some sort of, you know those requirements when they come, you say, no, we're not going to do them? They will come. And the problem, there are some requirements which can come, and they represent a cross-functional change, a change in a non-functional requirement, or maybe a new business area your business needs to handle, or maybe a new regulation. And we actually had that with a customer which needed to deal with a new regulation, and they actually had to go and implement it one by one in various microservices. Because the concern of handling with regulations and cross-cutting concerns was distributed among multiple microservices. Why? Because they didn't plan for it in the beginning. Now, I'm not saying that if you plan for it, it won't happen. It can still happen. Okay, surprises do happen. But when you plan for it, you at least minimize the chances that such things will occur. That's what architecture is for. That's why we architect, we design things before we build them. We did it with Monolith. We should do it with microservices as well. And with microservices, it's more common than you think that developers say, we don't need to plan. Another thing I hear is that services can arbitrarily call each other. Every service can call every other service. Now, again, it will work for 5 services, for 10 services, but what you have if you have 100 or 1,000 microservices? Is it still cool that everyone will call everyone as they want to? Probably not, because you won't be able to track the dependencies, and with all the services calling everyone else, you won't be able to upgrade your system over time and involve it over time. You lose control of what's happening, and then you get a distributed monolith. And that's the worst thing that can happen. You're better off start with a monolith. What can you do about it? There are various techniques that you can use. You can group services into layers so that each service in a certain layer can only call services in the layer below it. And I've done it various times. Or you can use an architecture where you group services into business services, which are larger. For example, services which handle inventory, services which handle shipping. Inside it's broken up, but we have these business services, and we govern the relationship between the business services on the higher level. So we kind of break things up a bit within the architecture. That really helps a long way when your system starts to mature and you get more and more microservices. Again, with 5 or 10, you won't notice, but you'll notice when you get to 100, 200, and so on. Another thing I hear, let's just throw the old code away. I'm sure each and every one of you has a piece of code in their system that they would like to throw away. You know that code that nobody loves, that there be dragons, like nobody wants to touch it. If you touch it, it will break. There's a reason that we don't want to touch it, because we know if we touch it, it will break. And the reason that it's there, that we're afraid, is that this code hides business logic that we need. So be careful when you throw away old code. And don't be afraid of doing it, but do it wisely. And again, prefer the evolution path over evolution. It will take longer. Again, the evolution path can take even 2, 3, 5 years, but you'll get there in a more safer way with less risks. The transition to microservices is a strictly technical issue. It isn't. When you want to move to microservices, this is a great opportunity to gather around all your managers, all the marketing personnel, all the UX personnel, everyone who is involved in the project, and get them on board. Why is it not a technical issue? For several reasons. For one, like I told you, no one's going to let you lock yourself up in a room for 3 years and come back out with the same system. Just not going to work. You need to get management on board. They need to approve this. They need to understand what they receive at the end. You need to explain to them. At the end, you'll receive better agility, better scale, we'll be able to move on, add features, and so on. But they need to also understand that during the transition period, they'll receive less features. Your velocity, your agility will actually decrease during the transition, and they need to understand that. Another reason to get them involved is that this is exactly the time when they can give their vision. They can tell you, our vision for the system in 5 years, in 10 years, what we want it to do. And you can incorporate it into your plan. Now, you don't need to build it right now, but at least you know where you're going. It gives you a much better vantage point for planning your system. So microservices, like monoliths, they start with good intentions. We have these small pieces, they're nice and clean. But over time, they become convoluted if you don't govern them, and then you get back to square one. Only this time, instead of having a bad monolith, you had a bad distributed monolith, and that's much harder to debug and monitor and whatever. I think you can pretty much agree that no one, today when we say monolith, we say it like with a bad approach, like monolith is a bad thing. But I'm sure, and there's a reason to it, because it usually gets convoluted over time because it's easy to get it convoluted. I'm sure no one here woke up one day in the morning and said, I'm going to write a bad monolith today. I'm going to ruin everyone. No, you didn't. But it became so over time. With microservices, it's the same. So don't just simply write a microservice system one day, plan ahead, use rules, use architecture. And people, developers and companies, over time, a lot of times don't do this, more than you think. And then they get back to the movie we saw in the beginning, which, like I said, is based on a true story. And the last one, which is also the most important one, in my view, is learn the essence of what is microservices. Now, for all of these years, software architecture wanted to achieve two things. High cohesion, meaning that every class, component, assembly, service, whatever you call it, should do one thing and should do it well and should have one reason to change. And low coupling, meaning we want to have as little coupling between components or services as possible so we can evolve them separately. Now, we do need to have some coupling because if we have no coupling at all, we have no system. The services need to interact with each other, but we want to keep it as low as possible. Now, a real-world example of this is that we came to a customer which built a new system on microservices. And when we reviewed their design, it was actually pretty good. The service decomposition was good. They got high cohesion. Everything was great on that regards. But they forgot about low coupling between the parts. And what they had is that while they used Kafka in their case to send messages from one service to another, the schema of the messages was shared across all services. So everyone were coupled to the same message schema. If I changed the schema of the message, I had to redeploy all services. They had one central database with one schema. Again, any change to the schema would require an update to the entire system. They did use Kubernetes to host and manage the services, but since each service had state, there were stateful services, at least some of them were stateful services, they were coupled to the physical machine. That's another type of coupling. You don't need to be only coupled to a database, you can be coupled to a machine because you store state on it. And then if that instance dies or the machine dies, well, you have a problem. The result, again, like I said, the microservice monolith. The fix here was rather easy because the decomposition was great. We broke up the shared message schema. We broke up the central database. Again, this brings up another issue of eventual consistency and how do we store data in multiple data sets. That's a topic for that's the topic for a whole another session. And we obviously removed the state from the services because Kubernetes excels at stateless services. You can have stateful sets in Kubernetes, but you really should know what you're doing before you approach that kind of solution. So to sum it up, microservices, it really is, it's the fashion, it's the future, it's cool, everyone's doing it, everyone's loving it. And really, microservice architecture achieves what we want. We get low coupling or lower coupling than what we had before, and high cohesion because every piece is small, it's individually deployed, individually maintained. And we all want to develop faster and deploy every feature as soon as it's done and have versioning independent code. We want to monitor everything. We want to do advanced processes like canary testing and A/B testing. And microservices allows us to do just that. But does it really come for free? The answer is no, it doesn't. You have to know what you're doing. Microservices comes with cost and responsibility. If you do it right, it will be great. It will get you scale, it will get you agility, it will get you a lot of good things that we want. But if done wrong, you get a distributed big ball of mud, you can't monitor it, you can't debug it, you're in a worse position than you were before. So Monolith is not necessarily a bad thing. It's another approach, and it can be done right. You can do design architecture Monolith and have it written in a very good way. And that's a valid solution for various problems out there. So do it right or don't. Use infrastructure and tools where possible. If you can use a public cloud vendor and use some sort of PaaS platform like Azure Kubernetes Service or Elastic Kubernetes Service in AWS or in Google, then you're in a much better point. You have a much better start. If you do it on-prem and you have to do it yourself, then you should account for it. You should educate yourself. It's going to be harder. When you have an existing system, decide if you want to migrate it or start from the beginning. Prefer to do evolution, prefer to migrate. It's not always possible. Take into account that the evolution can take several years to complete. And that's fine. But you have to take into account that this period will let you have less agility, less velocity. Consider the learning curve. Like I said, you have a lot to learn. Architecture, technology, DevOps, Docker, Kubernetes, and so on, depending on your developers. And remember, it's not just a technology change. It's a culture change for the company. Sometimes it comes in with DevOps, sometimes with Agile methodologies. It really depends on your company. But you have to start thinking in a microservices way. You might have to change the composition of your development teams so that the teams will align better with the microservices you choose, so you can set responsibility for each microservices and so on. So it's not just a technology change. This change is much bigger than just changing the code. So hopefully you won't get in this situation once you've seen this session, where everything blows up once you go with your microservices. And that's it. Thank you very much for your time. And we have time for questions.
Let's say you moved Monolith to, let's say, 20 microservices, and you have some page which should call each of them. How do you handle the latency?
Okay, so you're referring to scenario where we have a monolith, we will break it up, and eventually if we have a business flow which requires all of these services, we need to go one by one. And that's the chain you refer to. Well, so if you really have such a workflow that you have 20 services which you need to call synchronously, sure, that probably means your decomposition is not good. It's probably a smell that something was decomposed not in an optimal manner. A lot of time with functional decomposition, like I said before, this is what's going to happen. But let's say you did decompose well and you did do the right thing. There are various patterns that you can use. So for example, if you take something like a pattern like a materialized view, but not in a database form. So what you can do is that you can have a service which manages this view or this state, and you can build this view behind the scenes so you have all the data you need there at once. If we're talking about where maybe it's not a read operation, but it's the operation we need to change state or manage data, then you might want to not do it synchronously. You might want to do it asynchronously with queues and such, so latency doesn't matter in that regard. It also makes it much better because when you do everything synchronously and you have 20 calls, most probably one of these calls will fail, and then you have a problem with the chain because you need to revert some of the changes because usually you don't have transaction support there. So in general, that's something I would try to avoid at all costs, and it sounds usually like a smell in the decomposition. It's back there.
Yeah, so how can you establish a proper communication between services if you don't share a contract between them, if you don't share the message schema?
Okay, that's a great question. When I said they share the schema, I mean, you shouldn't share the schema of messages between all of the services. Have like one central, let's say, contract declaration file with all of the messages. You obviously need to share schema messages, but you need to be sure and be very clear on who owns the schema. So for example, we can look at two patterns. Let's say we look at messaging. So let's say you send a command to another service. So the schema of the command message, it's not shared. It's owned by the destination service. Now, you can read it as an artifact when you're developing your client, but it's not an entire system that's dependent on the same exact schema. Only those who are dependent on the service who owns the schema, they have the dependency on it. And the same thing vice versa. Let's say we have a common pattern is to have notifications in the system, like pub/sub. We want to notify everyone that something happened. So in this case, the dependency is reversed. The service getting out the notification, this is the service which defines the schema. Now, the only other services which need to know of the schema are the services which directly get this notification and need to handle it. Now, you obviously need to share this schema, so it really depends on what you're doing. If you're doing REST APIs, you can use Swagger or Open API definition. If you use gRPC, you can share the protobuf files. Actually, with some companies, what we've did is that, for example, if you have multiple microservices, and let's say most of the microservices are written in the same language, let's say C#, then what we did there is instead of every service which needs to communicate with another service gets the Swagger file and generates their own client, which is a valid approach, what we did is that we generated the client SDK and published it as a NuGet package or NPM package, and depends on what you're doing. And so every consumer consumed this package. Now again, there's no real coupling there because it's not a central thing. Only those who need access get it. There is some coupling, but it's minimal. And assuming you support versioning as well, which is what is required for microservices in the first place, you can upgrade the server without breaking the clients because they can still use the older version. So that's like the goal of it. There's one up here.
Hi.
Hi.
My question is, could you take real examples of companies which migrate from Monolith to microservices and when it was really proper?
When it was proper? Sorry, I didn't hear the question.
Yes.
Okay, so like I said, the ideal solution of moving from Monolith to microservices, there are two good reasons. One is that you don't have enough scale. You need to scale the system better, or you need to have more developers working on the system, or the best answer is agility. If you find yourself that you have a large code base and it takes you a lot of time to get code from the idea, even from the requirement to development to production, if that takes long, then these are excellent reasons to go to microservice. But the key thing here is to understand that this is a process which is time consuming. It costs a lot of money because developers are expensive. and you have a transition period. But once you do that, actually a lot of the customers that I talked about actually eventually have a good experience, because once you get through the transition period, there's probably always going to be a small part which is going to be part of the monolith, because maybe it's some sort of old code that's not important enough, so no one's going to touch it. But for example, in the e-trading system I talked about where we revolutionized, we got within, again, 12 to 18 months to a situation where most code was in the microservices, and they were running on AWS in the Elastic Kubernetes service. And they actually got much better scale and much better latency, much better performance from the point of view of the users, because we were able to scale individual parts of the system much better. And actually the business there was thrilled with the work which was done, and I don't believe they could have continued much longer with the monolith path, because they reached a certain point where the code base was big enough, they had a lot of developers, and it was very hard to scale with the existing technology they had, which was like an ASP.NET Service and MySQL, and that's it. So I hope that answers the question, but I'm here if maybe I misunderstood it. Another question?
We have no time left.
So. Okay, so I'm here, there's a break now, I'm here, feel free to come by, and thank you very much for your time.